All right, another gas stoichiometry problem. In this case, we know that we are reacting 0.5 moles of carbon disulfide, so this substance here, and it's clearly producing a couple gases. And we want to know how much space these gases will take up. So we know the temperature of the gases that are being produced. We know the pressure of the gases that are being produced. And we're looking for the volumes that are being produced. So as often is the case in stoichiometry problems, the missing piece are moles. So we ask ourselves, if 0.5 moles of CS2 reacts, how many moles of gas are going to be produced? And according to this, for every 1 mole of CS2 that reacts, we're actually getting 1 mole of CO2 and 2 moles of SO2. Now it doesn't matter which gas is which. All gases, for our purposes, behave the same in this case. They take up the same amount of space, exert the same amount of pressure. So all we really care about is that 1 mole of CS2 will produce 3 moles of gas. And we're assuming, in this case, I guess, that all the oxygen needed is being used up. We're not going to count the oxygen as part of the gases that are affecting our answer. We're just considering the products. So half a mole of CS2 can make 1.5 moles of total gases, and that is what is going to be taking up our space. So that is N in this particular case. Our temperature is 25 degrees Celsius. I am going to just skip right ahead and write it in Kelvin. We never want to be writing in Celsius. The pressure is in atmospheres. That's nice. We like it to be in units we can work with. So again, we have moles, we have temperature, we have pressure. We are looking for volume. So PV equals nRT is our ideal gas law, which means V equals nRT over P. Let's plug in. So our volume is going to be 1.5 moles times 0.0821 liter atmospheres over mole kelvins. You should have this memorized shortly. You don't need to, but you probably will have it memorized, times 298 Kelvin, all divided by the pressure of 4.23 atmospheres. So 1.5 times 0.0821 times 298 divided by 4.23. I get my answer is 8.68 liters is how much space this will take up. Notice I could not use the 22.4 liters per mole in this case. I'm not writing that right at all. Liters per mole, because it was not at STP. That is only at STP, and this was not. This was at 25 Celsius and 4.23 atmospheres. So I had to use the ideal gas law here. And that is our final answer. All right, so until next time, I am Derek Genova, and have a delightful day.